All right. So here's what we're working with. We're working with the ideal gas law. Now you've learned all these other gas laws. Boyle's law, Charles' law, Gay-Lussac's law. Avogadro's law is new, but you're not required to know that in this class. I'm just showing you this because I'm showing you how we put together the combined gas law with the Avogadro's law to get the ideal gas law. And most of the time, the ideal gas law is written in this form. PV equals nRT. R being the ideal gas constant or the universal gas constant. Sometimes it's called the perfect gas constant. Okay? Now, you always have R. Okay? R is listed for you. It's listed on the front page of your test references. So if you don't have out your test references, first of all, shame on you, but get them out.
Ooh, I got mine out.
Good for you. All right. There you go. He's going today. He's Charles in charge today. If you look on the first page, at the bottom of the first page, you'll find the universal gas constant. Okay? The universal gas constant doesn't change. It's exactly the same every day, all day. Okay? It's exactly the same every day, all day. There it is. Why is it, if they're exactly the same, do I have all these different numbers?
Different states.
They have different units of measurement. You use the one that fits your problem. We'll get into that, okay? Now, listen up. Imagine for a minute that I've got a dozen things in this hand and 12 things in this hand. Really? Different numbers? All we're doing is using different measurement systems, right? Suppose I've got 100 pennies in this hand and $1 in this hand. Different numbers. But they're the same thing, right? Because they're measured differently. This is measured in cents. This is measured in dollars. 100 versus 1. Same thing. Same thing here. R is the same. The only reason the numbers are different is because they're measured in different ways. Okay? All right. So here's our problem. Now, back when we were learning about all those gas laws and how to solve them, Boyle's law and Charles' law and Gay-Lussac's law, even the combined gas law, we said there was a system you were supposed to use for solving these problems. What is the first thing you do when you're solving any of these gas laws? Write out your list of knowns and unknowns, okay, using symbols, okay? So pressure, I was real nice to you. I tell you it's a pressure here. That's P equals 785 torr. Okay? Then we've got a volume equals 12.5. Capital L is what we use for liters. We said that when you're solving gas law problems, your temperature must always be in what units? Kelvin. Now, I gave it to you in Kelvin here, but if I gave it to you in Celsius, you'd have to change it to Kelvin. Okay? Add 273.15, but really you don't even have to memorize that because I gave it to you on your test references right here. Okay? So, the temperature is already in Kelvin. T is temperature, and that's 290.0. It's kind of sloppy, but 290.0 K. Okay? And then we are trying to find moles. What's the symbol I told you for moles a while ago? N. So N we don't know. Okay? So what equations do we have that have all of these variables? The ideal gas law. Okay? That has all the variables. This is not a variable. This is a constant. You always have it. You have to figure out which version to use, but you always have R. Okay? Which version of R, which version of the universal or ideal gas constant are we going to use in this case?
62.37.
Wow, very good. How did you figure that out?
It has torr in it.
It has torr in it. Okay. Has units of liters. Okay. It has torr, the pressure unit. Okay. It has Kelvin, the temperature unit. And it has MOL, which is moles. So it has everything we need. Does that make sense?
Yeah.
All right, now, I want to take and sort of step back just a second and give you a warning. Now listen, these over here, these are not variables. What I say? These are units of measurement. You cannot plug in this measurement for a unit of measurement. You can only plug in this measurement in a variable. Okay? These things, pressure, volume, temperature, get plugged into the ideal gas law. They don't get plugged into R. You got me? If you make that mistake, fair warning. Okay? This is a big problem with a lot of points, and you'll probably get a 0 or close to it because the only thing you got right was maybe your list of knowns and unknowns and the value of R. Okay? These are units of measurement. They're not variables. You can't plug things in for that.
What was the mistake?
The mistake is that people want to take this measurement and plug it in for this. Can't do it. Don't do it. Don't even consider it. Not done. This gets plugged into the gas law. Got it? Yes.
So if you put 62.37 liters times,
And they'll take 62.37 and plug in 12.5 liters and plug in 785 torr and plug in 290.0 K and solve for M.
that's not
No, you can't do that. These are units of measurement. They're not variables. You can't plug things into this. You only plug things into this. Right. All right. Are we ready to get started then? All right, let's plug in what we know. We know the pressure. We know the volume. Okay, so we got pressure and volume. We don't know N, so as we learned when we're solving gas laws at the beginning, we're going to leave N as just a symbol then for now. We know R. R is this thing, 62.37 liters times torr over Kelvin times moles. Okay? All right. Now we got to multiply also by T. T we know is 290.0 K. All right, think back to when we're solving gas laws. What was the next step after we plugged in the knowns and unknowns in our... Well, there is crossing out to be done, but we're not quite ready to do that yet. We have to set this up over here so we can cross out. We've got to get the unknown by itself. Our unknown is moles, N. Okay, we've got to get it by itself. And the way you do that is to multiply by those things on both sides of the equation that will allow us to get N by itself. Okay, you're going to multiply both sides of the equation by things we're going to put on there that's going to allow us to get N by itself. Now here's what we're going to do. We're first going to multiply by the inverse of this. We're going to put Kelvin times moles on the top and 62.37 liters times torr on the bottom. But if we do it to this side, got to do it to the other side. Kelvin times moles over 62.37 liters times torr. Okay?
Now we cross out.
We can cross that out. You're right. Let's go ahead and do that. We can cross all this out here because we got that there. All right. We also got to get rid of this. All right? How do we get rid of this part? Okay? Or we can put it 1 over that, either one. 290.0K. If I do it to this side, fill in the blank, guys. If I do it to this side, got to do it to the other side. 1 over 290.0K. Now I can go over here and cancel this out. And lo and behold, I've got n by itself. I'm waiting. Oh, I'm not going fast. You're going slow. Come on.
You know this.
Well, I know it's kind of small, but in order to get it all in on one page, I've got to kind of make it small. You got to listen. Okay.
Now what?
Well, let's see. Can we simplify what's on the left? How about if I put this over 1? Is that going to change that value? No. Now can you see what to simplify? I'll tell you what, let me go ahead and lower the camera a little bit here. Since we fixed this right hand side already, okay, I'm going to go, let's just look, zoom in here a bit on the left hand side. Can you see now what to cancel? Tor goes away. Sure, top and bottom, that's it. K can go away. Alright. Anything else? Leaders can go away. Hey, what do we have left here? And what does that measure? It measures what we're looking for over here. Okay? Moles. Moles. That's what we're looking for, isn't it? We are ready to plug it in the calculator. It's that simple. $785 times 12.5, and the way I taught you to do this works on every calculator. There's a lot of operations on a calculator that don't work from one calculator to the other, but this one works on every calculator that I know of anyway. So 785 times 12.5, you go ahead and enter on your calculator, or equals on your calculator. Then you're going to divide by 290.0K, or just 290 actually, and go ahead and enter again. Then you can divide by this last number on the bottom here. Okay? Yep. Yes, you do. 0.542507726 Now you may have a few less digits, but that's okay. What units of measurement do I have left? Moles is left, so I got to include that. And moles does equal N. That's what we're looking for. Okay, we need to underline all the insignificant digits. How many digits do we need? 3. I've got, of the measured numbers that I have in here, measured calculated numbers I have in here, I've got 3 digits here, 3 digits here, 4 significant digits here, and 4 here. We want our final answer to have the same number of digits as the measured or calculated number with the least digits. So we want 3 digits. Leading zeros are not significant. 1, 2, 3. Underline from here over. Draw an arrow to show that we're rounding off. And write our final answer. 0.54. The 5 makes the 2 round up to a 3. Units of moles equals N. Box, period, done.